That's our little breakover. We'll take a little longer one next time. Just 5 minutes is enough for now. So we'll keep the momentum going on this topic. Second part of inheritance, interface inheritance. So we've looked at the extends keyword, use of super and abstract, the 3 reserved words that define the use of implementation inheritance. Now we need some other keywords here to explore a different concept. Interface inheritance, we talk in terms of types and subtyping rather than classes and base classes. The terminology is not terribly important, but it is a subtle shift, and it is more in line with current thinking to use this phraseology rather than to rely on the older terms. Still the same concept as such. We still talk about generalization and specialization, but we realize it quite differently. So let's look at a definition, particularly what interfaces are, how it's implemented, some discussion on typecasting, which is relevant to both, in fact, and then some naming conventions. And then we're kind of in a good position then to move on. We're comfortable, hopefully, with the idea of a class at this point. Class has attributes and behaviors. That is, it has methods and also fields as we've been implementing them. Java also has, as a first class representative in the language, a companion to classes called interfaces. Interfaces are superficially resembling classes, but substantially different. Interfaces contain largely only methods, and those methods are abstract. They're signatures, not implementations. They can contain, in general, fields or attributes, and nor can they contain, in general, constructors. So they're close in concept to abstract classes with all abstract methods. Now, this has become blurred a little in more recent versions of Java. So Java 8 and 9 have finessed this concept a bit, and Siobhan will be taking you through that a bit later. So we'll keep it simple for the moment and assume it's the earlier definition. Here's an example of an interface. Looks like a class, except we don't have the keyword class initially. We just have the word interface. That replaces where we would normally put the class keyword. And also note that we're not using the word abstract anywhere, but we are terminating each method with a semicolon, like an abstract class. And there are no implementations of those methods in the class definition. So we say in computer science terms, this is a type. It represents a concept that has behavior, but not representation. I can do things with this, but I can't open it up and look inside it because it has no embodiment. Classes are used then to implement interfaces. So we're looking at the class address book. Instead of using the extends keyword, it's using the implements keyword. And this is establishing, we could say, an inheritance relationship to address book, but we think more in terms of a subtyping relationship, to use a more convenient terminology. And what that means is that this address book class must implement all of the methods defined in the interface it is intending to implement. It must, if you like, fulfill a contract here and fully realize these signatures. So we say the classes are subtypes of the interface, and the compiler will insist on that implementation being realized. We don't have a choice about picking and choosing which methods we implement. They must all be implemented. In fact, we kind of regard it as a contract. we are adhering strictly to a contract laid out in an interface, and we are, if our program compiles successfully, will have guaranteed to implement the interface. We do also have the ability to implement multiple interfaces. So the relationship we explored in the closing of the previous session, whereby we had a desire for a class to implement two other classes, well, we can approximate this here now with interface inheritance. And it's not uncommon for classes to implement more than one interface where it's appropriate. In example, car, a color, a colored car. And here we notice we're using the extends keyword. It looks a little bit odd, but we're in the interface world here, so it's reasonable for us to extend other interfaces and multiple interfaces if necessary. So we're not saying implements here, we're saying extends. Any class now that realizes colored car will be implementing those two interfaces as expected. We'll be looking at the collections framework very shortly, and here an understanding of interfaces is quite important. You've already been using array lists in your labs, in your little projects. In fact, you may also have explored very briefly a linked list. These are two classes in the collections framework, and both of those classes implement independently an interface. And that interface, that instance, is the list interface we'll be looking at shortly. When you introduce a variable, you may choose to associate the type of the variable with the base class, with the interface or the base class. So here is a product object. It's declared to be ostensibly an interface, but we realize it by selecting a concrete or implementation class, that is the array list. And this type of pattern will be quite common in your labs to date and in much of the code we implement. We'll return to exactly this concept shortly again. Now, most statically or strongly typed languages do have a typecasting facility, and we use this to override the language's default typing behavior when we are certain that we know a specific type is available, but hidden in the context of the current class structures. When we create objects, we can choose to associate the objects with the base type, as we're doing here. And similarly, with our address book example, we're associating the book class with an interface, the interface being iAddressBook we just looked at. So both of these examples, one using implementation inheritance, the other using interface inheritance, the objects we're using, policy and book, are typed to the base, not the derived. Now what that means is that for interfaces in particular, we will not be able to access any concrete methods unless they are defined in the base class. So if I apparently want to make an attempt to call a method locateIndex on the book object, unless locateIndex is defined in the iAddressBook interface, this is a compiler error, it's a syntax error. Normally, we're happy for that error to be detected. It means we've misconstrued our logic in some way. However, there is a way around it. And this is the typecasting syntax you may see occasionally in Java code. If we know the object refers to a concrete implementation, we can force the compiler to override its reservations and invoke, in this case, the concrete method. And this is the syntax we're using here to do that. We're saying, I know it's a book, force it to be an address book object, and then now invoke the locateIndex method on that for me. not very attractive code. If we saw a lot of that occurring, we'd be raising some questions as to whether we were using either inheritance or interfaces appropriately. And we might be considering a reassessment. However, in certain circumstances, it's unavoidable, particularly when you're dealing with large and sophisticated Java frameworks. It's quite common in the Android frameworks, for instance, for you to use this type of syntax occasionally when you're interacting with Android framework objects in certain contexts. These are common naming conventions. There's no real set standard in this area, and in fact the JDK itself has a couple of different variants on this. We will, though, or we have seen a serializable already. Serializable is an interface defined in the JDK. It's a curious interface in that it has no methods. It's sometimes called a marker interface. So it's merely saying I have a type, but I'm not actually committing to any signature for that type. These other ones are also visible. Clonable does have some methods, and transferable, I think, is in some frameworks. I don't think it's in the base class SDK. Another style of naming these interfaces is to use the I in front of the name, I color, I car, I colored car, etc., and then remove the I for implementations. And yet another style is to use standard names for the base types and use impl for the implementations. That was a style very common in earlier distributed systems. No hard and fast rules, really. They're just common naming conventions we encounter occasionally as we're encountering legacy code or particular usage patterns in individual frameworks. That's interface inheritance. Core idea really, or interface inheritance, is that we are defining not classes but interfaces. And when we define those interfaces, we are defining effectively a type, and that type then must be fully realized by any classes that choose to adopt or implement that interface. Implementation inheritance has some similarities, but the starting point is existing classes, and these classes may be partially or even completely implemented. And then inheritance in that context is augmenting or maybe overriding the implementation. I've mentioned at the start that their sentiment has swung quite strongly away now from implementation inheritance to such an extent that some modern languages no longer support it. However, they do support interface inheritance. A good example of that would be Go, the new language from Google. It closely tracks Java in many respects, but completely drops the former type of inheritance and relies exclusively on the latter in that instance. Okay, taking our short break, and our next topic, we're going to be looking in detail now at what we can do with inheritance, in particular how inheritance allows us to build and use the very powerful collection frameworks. So I'll give you 10 minutes if you don't mind. I'll attend the chat room if anybody has any issues, and we will resume in 10 minutes.